Hello, I'm Naku from SoftUni, the software university, and I'm here again for the next lesson from this free Java Foundations course, which, as you already know, covers important concepts from Java programming, such as arrays, lists, maps, methods, strings, classes, objects, exceptions, and some Java API classes. And this course prepares you for the Java Foundations official exam from Oracle. In this lesson, I will explain and demonstrate with live coding examples some frequently used Java API classes, which are part of the Java Foundations official exam from Oracle. I will talk about the math class, how to generate random numbers using the JavaUtil random, how to use the JavaUtil arrays class, how to format strings using the JavaUtil formatter, and how to perform calculations with large numbers using BigInteger and BigDecimal classes, and how to work with date and time in Java using the java.time API. Let's start. What shall we learn in this lesson? In this lesson, I'll talk about first about the math functions provided from the Java Lang math class. Next, I will talk about random numbers and the random number generator from the JavaUtil random class and how to generate random numbers in certain range. Then I will talk about array manipulations and will demonstrate you how to use the JavaUtil arrays class for sorting arrays, for constructing arrays, and manipulating arrays. Then I will talk about format strings and how to use the JavaUtil formatter class in a way similar to systemout.printf. Then I will explain how to use the Java Lang BigIntegers and Java Lang BigDecimal classes, which provide arithmetic for working with big integer numbers, for example, with 10 million digits, and big decimal numbers, which can hold currency, money, or financial calculations, and which behave correctly and don't make mistakes with arithmetics, unlike the system double type. So finally, I will finish this lesson with introducing the Java time and date time APIs, the API from the java.time package, and I will show you how to work with dates, how to parse the date, how to read the date, how to construct the date, how to make calculations between days, for example, how many days are between two certain dates, and many others, how to format dates. I will mention also the locale and how to deal with different locations, such as, for example, France or Spain or others. Okay, let's start, but before that, I should mention that learning programming is done by coding. So if you only listen to these lessons and you don't solve your problems, you will not learn much. So we are ready to help you by providing you the SoftUni Judge system, which allows you to send your solutions for automated evaluation. And this is how it works. You open this judge contest. It's linked at many places in your lesson. So you click the practice button, and these are the exercises from the Java Foundations course, and you choose an exercise, you put your code, and you submit. So, for example, if I have this solution, for example, I can put this code, submit, and after a while, I'll have a result, for example, this one. So, this is how it works, and I hope that you will use it, because writing code and training your practical skills is much more important than listening to talks, watching videos, reading tutorials, etc. Learning coding is only done by coding. So please code. Don't forget the exercises. I will mention them many times during this lesson and during all my courses. So let's start with the Java math class. I'll talk about the round, the P function, calculating maximum, minimum, cell and force for cutting up to integer up and down, certain floating point number, absolute value, raising a number to certain power, etc, etc, etc. So java1.math provides basic numeric operations. So some operations are built in the one language, for example, the plus operator, which sums two numbers, but some others are not, for example, calculating a square root. So the operations are invoked by typing math.something, and I'll show you some examples, like double round equals to math.round, which rounds in the standard way the given number to the closest integer, up or down, depending on the number. This is a way to access the p constant from mathematics. You know it from the calculating, for example, circle area requires using the p number, and calculating max, min, etc. Let me show you all these examples. I'll start IntelliJ IDEA, and I'll create a new project which will be called, for example, okay, I have already closed the project from the previous lesson, but I'll create a new one here. It will be a Java project and command line project, and it will be called API classes, for example, classes examples. Why? Because the name of the project should match its purpose. So the purpose of this project is to give you some examples for some Java API classes. So I can give this number. I can even use spaces here in the project, hyphens in the project name to make it easier to read. So this is my project, and it holds just a single main class. I'll hide this, and this is where I write my code. So how I use the Java Math package and Java Math class, this is how. For example, I can show you some of this. Double round equals to math.round of 25.5. This will print rounded, will print 26. For example, I will run this with right click and selecting run. Okay, but it is not integer, so it's easier to, sometimes we need integer value, especially when we round, so we'll do this typecast. This is a better approach. So if we have 25 down 29, for example, like this, it will be 25, the result. This is a traditional rounding. If we have dot 55, it's bigger, it's closer to 26. If it's exactly at the bound between 25 and 26, the bigger is taken. Okay, so we can math.p, we can print it. In IntelliJ IDEA, we can press .s out, and this will print out this one. This is just a shortcut, a template in the editor. So this is the value of p constant. We can use max and min, like it's shown here in the example. How does this work? Cell rounds up, but to the closest number upside. So cell with 25.001 will end up in 26. Okay, with 25.0 will end up at 25. With 25.99 it will end up in 26. So this is rounding up, and 4 is rounding down. if it just takes the integer part and removes the part after the decimal point. Okay, so this is how I explained already this. math.abs calculates absolute value. For example, we can calculate math.abs absolute value of 30, which is 30, and minus 30 will be minus 30. It works as well for decimal numbers like this, so it is as expected. And raising a number to the power of another number, for example, 2 raised to the power of 5, for example, we can calculate with this. So let me show you this. Math.power of 2 at 5. But this works with real numbers, and if you want to take the integral part, you can just typecast like this, or use math.for of this, and then use this typecast. But you can use the power like this, for example, 2 at the power of 5.5, which is interesting. It's not I'm sorry, it's not so clear which will be the result, but it will be something between 2 raised to the power of 5 and 2 raised to the power of 6. Okay, between 32 and 64, it will be something like 5.5. It will be something between, it is 45 point something. So we can even raise minus 2 power 3 of 3 to minus 2.3. Oh, it's not allowed, like we see. Yes, negative power, negative to the negative numbers cannot be raised to a power of such number. So this might work, I'm not sure. Yes, but when it's not integer number, this is not defined. It's not quite important now. The important thing is that you have the java1.math class, this class, java.wank.math, or if we put the mouse, the IntelliJ IDEA will give us some help, some documentation for this. Java1.math class has all these calculations already implemented. An interesting feature of math.random of Java1.math is the random number generator, which is not very powerful, but it basically generates a random number between 0 and 1, excluding 1. So we can do something like double rand equals to math.rand random number. Okay, give me a random number, and I can print this random number. So if I run this program several times, it will give me a different value between 0 and 1. Do you see? And it might give me 0, but it cannot give me 1. So it's interesting if I need a random number in a range. For example, if I need the range from 5 to 10, I would need something like rand multiplied to 5, and this will give me something from 0 to 5, excluding 5, from 0 to 4. Okay, and it will give me, and I will need to add 5, and this will give me from 0 to 9. So if I need from 1 to 10, I will need to add from 1 to 10, this will give me from 0 to 4. If I need from 1 to 10, I'll need something like this. So I'll make a loop for I, for example 100 times or 1000 times, and I will print out in the loop something like this. This is a very basic calculation. I'm not sure it's exactly correct, but it's, oh, do you see math.random? It's already calculated here. It should be different at each step of the loop. Let me show you what will happen. So I want from 0, this is from 0 to 1. If I multiply it, then yes, and I will need to truncate it to int like this. So this is how I reach numbers from 1 to 10. Looks like I have 1, I have 10, I have all of the others. But it's quite complicated, so I will show you another way to generate random numbers more reliably. Let me focus on this pseudo-random. Pseudo-random means that this number is not really random. It's imitating a random number. How? By certain calculations and taking some input from some events which can be considered random, the so-called entropy, which is taken from the CPU, from the hard drive, from the network card, it's at the operating system level. The entropy, for example, when I move the mouse, it generates entropy. When I talk to the microphone, this generates entropy. So it takes some hard to predict information and generates a sequence of random numbers based on it. But it's not safe for cryptography because it can be calculated. So it's a long story, but in short, cryptography needs more secure random number generator. This is the output from this example, and now I'll show you the java.util.random and how to generate pseudo-random numbers in Java. So let me show you this class, java.util.random. It's a class which is a pseudo-random generator. It's a generator of random numbers based on a formula, based on mathematical calculations which start from certain seed. Seed means a starting value, and there is a formula which transforms this starting value to another starting value, and there is another formula which generates a random number in certain range based on this seed. I'll show you how this works. So to use the Java util random, we need to have to create a random generator, a class, an instance from this class, and the random generator can call the randgen.nextInt of 6. So I can generate the next integer of range from 0 to 5. This means 6, and if I add 5, it will generate a number from 5 to 10. Looks more easier than this hard to read calculation, right? And also this random generator has, how to say, better formulas, it's recommended over Java math.random function. And this is another API where we can request from the random generator next integer in the range from 50 to 100. So it's always exclusive. So if you want to include 100 itself, we should specify it to 101. Okay, let me show you how this works. So if I use a random generator, random randgen. It is a random generator. I will import this Java to random, pressing Alt Enter in IntelliJ IDEA. So it's new random, okay, and I will not put a seed here. So I'll just use the random, and I will print random number in range from 5 to 10, for example, and it will be random generator dot next int. So I have next boolean, double, I can use next long, I can generate sequence of bytes, for example, if I need, for example, random passwords or something like this. So I'll use next int in range. Next int alone will generate a random integer number in the whole size of int, from -2 raised to the power of 32 to 2 of the power 31, something like this, the whole range of int. But if I run with parameter, invoke this with parameter 10, it will be from 0 to 9, because this is upper bound but exclusive. I can use 5 to 10, but I need to put 11 to include 10 itself. So I'll have numbers from 5 to 10. Let me show you 5, 10. And also the probability for each number is equal. This is guaranteed by the random generator. So if I generate 10 millions of random numbers in this range, it should be expected that we'll have equal number of 5 and 6 and 10. Okay, so this next int comes from Java version 17, so it will fail on earlier versions on Java, but it is easy to use it. So if you generate from 0 to 5 and you add 5, you have a number from 5 to 10. But I'll need to put brackets here, because otherwise the concatenation with strings will give me a wrong value. So I have from numbers from 5 to 10. Okay, so this is how the random generator works, and it's recommended to create it once and then to use it many times. So if I want to have 5 numbers like this is how it works. If I fix the seed, for example, this is the initial, the starting number of this sequence, and I run the program many times, it will generate the same sequence. See, 7, 10, 10, 5, 7. If I run it again and again, it will generate the same sequence. This is how the seed works. Seed, if we don't provide seed, it will be taken from the system entropy, from the operating system. But if I use the seed, specify the seed, I will fix the random generated to a certain predictable sequence. Okay, so this is how it is explained. If I press this, if I initialize the seed like I already explained, and I generate a number in the range from 1 to 1 million, for this seed it will always be this number. Did you see this one with these underscores? This is valid in Java. So in Java I can use numbers like this next in of 1 million, for example. I think I need one more bracket, and it is not 1 million, it is 100,000. So to improve the readability, I can put the underscore, and the underscore is just ignored. I can put it anywhere in in integer numbers. No, not at the start, obviously, but I can do like this, and it's the same number, 100,000. It's recommended to use this one, and this makes numbers more readable, as I already explained. Okay, so this is how the random generator works. It's more obviously more correct to use this message. And let's go ahead to solve a problem. I already mentioned that if you want to become a developer, you don't need just to watch videos, but you need to write code. You need to create projects, to create programs, to solve problems. And I have prepared problems for you to train your skills. So you are assigned to create a program that generates a random number in given range. So you read the start and end of the range, and you generate a number. The number from 1 to 10, from 50 to 100, or etc. So this is a sample output. It would be random, so it will be different at each start of the program. And we talk about integers here. It's not specified in the problem statement, but this should be integers, integer numbers, random integer number, random integer number. Okay, so let's solve this problem. I will create a new class here, new Java class, random in a range, for example, random in range. It's always recommended to have the name of the class to match its purpose. So what's this? Something which deals or generates or does something with random numbers in a range. So I'll have scanner equals to new scanner of system.in, and from this scanner I will read the starting number, int start num equals to scanner dot next, give me the next integer, then give me the end number in the same way, and int random equals to generate random in range from start to end, and finally print me this random number. And I will need to create this. Okay, to create this without enter, I created a method, and here I'll do something like this: random generator equals to new random generator, and then I will return the random generator dot next int from start to the end plus 1, because I want it inclusively. If I say from 5 to 5, I will need a number from 5 to 5, not from 5 to 4. So from 5 to 6, 5. If I run it again, from 5 to 6, 5. Okay, someday I'll have 6. If I need a number from 100 to 200, works correct. From 1 to 1, it will be always 1. From 1 to 0, it will be an exception, of course, because it's invalid. It's not possible. But if we go here at the judge and we submit this problem, random number in range, it might have an issue because I'm not sure that the judge supports the latest Java 17. It doesn't recognize this, so I need to fix this to work with earlier versions of Java. So I'll have the end number minus the start number plus 1. For example, if I have from 5 to 5, I will need to have 1, not 0. So that's why it's plus 1 plus the start num. It's quite important to test whether this formula is correct. So if I say from 10 to 11, it's 10. I should be sure that sometimes 11 comes. Looks correct. Let me play it several more times. Sometimes it gives me 10, sometimes it gives me 11. It should be 50% chance, but looks like 11 comes more often, but looks like it works. So if I want to generate from 1000 to 2000 a random number, looks like it works correctly. So I generate a number in the range between the difference to the start and num, and I start and end, and I add the start. Okay, this is very simple calculation. I will not explain it much because you should just think a little bit and you'll see how it works. Let me submit this in the judge system again. So I have written this code, I send it for processing, I wait a bit, and it tells me that my solution is correct. So this is another solution based on math.random. It is quite complicated. If you use the older API, math.random, which generates a random number from 0 to 1, 14-point number, you need to specify the range, multiply by this, add the minimum, and finally truncate to int. Another way to use this is, you can use this solution, for example, which I already created. End minus start plus 1 plus start, or if you have Java, later version of Java, you can just put the range from start to end plus 1. Okay, let's solve one more problem. It's called randomized numbers. We need to write a Java program to randomize a given list of numbers. And we'll use the Java util random class, and we read the input integers until we reach end. So integers come as sequence, 1, second, third, etc., 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 until we reach end. And these numbers, we need to randomize them in random order and print them. This is a sample output. It might be different every time we run the program. And if we have only one number, obviously the output will be the same number. Okay, let's solve this problem. How do we solve this problem? We click at our source code, we create a new class called, what will be the name? Randomized numbers. There is already a name here defined. So randomize numbers, and in this class I will use public static void main. I will take this scanner because I don't want to write it again. Okay, and I will do something like array list of integers equals to new numbers, new array list of integers. So let me check a list of numbers, so integers, and I don't know how many are they, so I don't use an array, I use an array list. And because I don't know how many are they, I will write something like while true. I don't know when the loop will finish, but I definitely know that I will read many times from the standard input a number, and I will put it in the nums. So I will say something like string when equals to please read the next when from the scanner, and if the when is and, then stop the loop. Otherwise, please parse the num, int num equals to integer dot parse of the when I have read. For example, this one. It's not in this case because we have end and the loop will break. And nums dot please add the next number. And now I have the numbers. Or I can even extract a method like this. Right click, extract method. It is in refactoring extract method. It will be called read numbers. So it should return nums, and it will not be void. It will be like this. And so the first step is to read the numbers. The next step is randomize numbers, and the third step will be print numbers. It is quite easy to understand this code. Read the numbers, randomize them, and print them. It's obvious that we have these three steps, so I will press Alt Enter to create these missing methods. The arrangement could be better like this in the order of invocation. It's more logically to order the functions like this. Okay, so I read the numbers, then I randomize the numbers, and then I print them. Printing the numbers, it's something like for num in numbers, print num, something like this. Okay, printing is quite easy. It's recommended in most cases to have these brackets, even if we have only one command after the for loop. And how we should do this? I think if we have these numbers, okay, this is the arrays. This one, if I exchange it with a random number and do the exchange, it will be randomized. To randomize the second, I can exchange this one, the red one, with some random number, for example, this one, and I exchange this. At the third step, I can have this one, and to randomize it, I will exchange it with a random number, for example, this one, and I exchange this, and this is a classical algorithm. It is Fisher-Yates shuffle algorithm. It's very well known. You can invent it yourself. You don't need to read it, but basically it says that you go through the numbers and you exchange a number with an element with a random another element. So we'll need a random number generator. Rand generator equals to new random, and then we'll need for loop like this until the nums dot size. Okay, so I will have a random number here, and rand index equals to random generator dot next integer of the nums dot size. So I will have a random number, random index from 0 to the size of the numbers -1. So I will have random position from the array here, and I need to swap from these numbers index I with rand index. Swap or interchange. How do I swap? This is how I can swap this, something like int old value equals to nums at position 1. It's better to have position 1 and position 2. I'll first remember the position integer. What happens here? Array type expected. Oh, it's not array, it's get at index. Sorry. First I remember the old value at position 1. Then I put at position 1 the set at position 1 the value from position 2. Okay, old value at position 1. So I remember the old value at position 1. Then at position 1 I put the value from position 2, and finally at position 2 I put the old value from position 1. This is a classical algorithm for swapping two array indexes. So this is the randomization, and let me check whether this code runs correctly or not. So I have numbers, for example, 10, 20, 30, and 20, 10, 30. Looks randomized, but let me check again. 10 and 20, and 20, 10. 10 and 20 looks randomized. 10 and 20, if it is random, sometimes it should be the same. It's there are two permutations of these numbers, and both should have the same probability. Okay, so looks like it works, and let me check it in the judge. In the judge system, I have these randomized numbers. I will submit this code and we'll wait a bit. We'll refresh, and it looks correct. I wrote this without any mistake from the first time. It's not always like this, but I'm experienced developer, that's why I don't make much mistakes when I'm coding so simple things. I want to show you some other things that what will happen if you don't have integers, but you have some other types, for example, array list of strings. So I will need to replace here string, and here string, and here string. Okay, so can I make this generic? And the answer is yes. I define this type T, and here I use type T. Do you see? This is a generic method, a method which works for any class T, which can be integer, string, or other. So I could write like this, T, and this will be a type T. And now this one could also be generic, static of T void. It's generic, and now if I want to read strings, okay, let me first show you that this works as previously after this change, after I made them generic. 3, 4, 5, 6, 7, and looks like they are changed. So these read numbers will also be generic, and it will be read. It will be renamed to read elements. Okay, so it will be array list of t, and it will just read one by one, and this will be elements, not numbers, because these are not numbers. Array list of t, so here I will have array list of string, and I will read string array, randomize, it's not numbers, elements, and this will be not print numbers, print elements, because these are elements. So if I have looks like I have mistaken something here. Elements are of type array list of t. This should be t. Okay, I cannot. It should be like this, but I cannot make this generic with ease, because sometimes it needs to parse numbers. If this t is integer, I need parsing. If it is string, it needs something, but let's hack it like this. And just to show you, if you have Peter, George, Mariah, and we have some randomized order of the same input. Okay, this is what I wanted to show you, and this is an explanation of what I did, that I can exchange each element with some random element like this, and sometimes the element will exchange with itself, which is also random, and this is how the algorithm works. This is the easiest algorithm to randomize an array of elements, and this is some kind of implementation where I use generics and I use swap between. It's mostly the same thing which I already have shown to you. Let's continue with the arrays class in Java. I will explain how to use the slist, sorting, equals for two arrays, toString for array, and other operations. I'll give you some examples how to use this, and I will play with some code, and finally we'll solve some practical exercise to get more practical skills. So Java util arrays provides methods for manipulating arrays. It is part of the Java Collections framework. Java Collection framework is API which holds a bunch of classes, interfaces, and APIs to work with elements such as lists, arrays, maps, sets, etc. These are the interfaces: set, sorted set, list, queue, sorted map, and many others. So they have set implemented by hash table or balance tree, linked list, etc, etc, etc. So it's a API which is used by developers to store their data structures and elements. Okay, so let's go ahead. So in this class hierarchy we have object and collections are objects which can be of type list, map, set, or some other, for example, linked list. And lists can be array lists, linked lists, and many others. Maps can be hash maps or tree maps based on hash table or balanced tree, etc., etc., etc. And arrays are something, utility class, which derives from object, and it is related to these collection classes, but it's intended to manipulate arrays. Let me show you how this works. So the first interesting method is arrays as list. So we can initialize a list with ease using this API. Let me show you how this works. I will open this and will create a Java class, which will be called, for example, arrays examples, sorry, and it will have some public static void main. Okay, public static void main, and inside we'll have something like var list equals to arrays dot as list of, for example, Peter, Mariah, and Steve. So this will return a list of strings, and I can print it, and this will print the list like this. Sorry, I ran the wrong code. Peter, Mariah, Steve. This is the default to string for the lists in Java. Okay, if I want to make a list of numbers, this is extreme. 10, 20, 30. This is a list of integers. Okay, so I can run it like this, or I should use list of integer. Okay, to run this correctly. But if I use var, it's easier. If I use list of int, beware that this is not possible in Java. In Java, you cannot create a list of primitive type like int, boolean, double, etc. You should use its wrapper type, the integer with capital letter. Okay, what's next? We can create array as list from a list from array. So if we have array, we can create a list, but it should be new integer again, because otherwise this as list will not work. It works only for arrays of non-primitive types. So in Java there is a big how to say a big drama about these primitives and other types, and that generics don't work on primitive types. This is fixed in C#, but Java people have legacy and they can't fix it with ease. So it always has issues, like if you want to have a stream of integers, you do some special things, and you cannot do this directly. So how we can use this list? We can do something like list dot stream, give me stream for this list, dot filter elements e, which are bigger, than 10 or bigger than 15, for example, and var new list equals to this, new list, and this will work as expected. Oh, you have a stream here. It's a stream of integer, so we should print use toList in order to return this back to list of integer. So now it works as expected. So we can use also arrays.stream, and we can create a stream from a list of integers, for example. And now these integers can be like this, and they can be also like this. And both of them will work correctly. But see, stream of primitive integers is of type intStream. Stream of integer is like this. This is the big issue in Java, which is still not resolved. In Java 17, we have so many versions and improvements, but it's still not resolved. But basically, you can do operations like this. Let me show you some others. If you want to print an array, a normal array, for example, int array numbers equals to 10, 20, 30, for example. If I print these nums, it will not work as expected. It will print that this is an array of integers and this is the location in the memory for these arrays. It doesn't work like expected. So how we can fix this? We can use arrays dot toString of nums, and now it will work correctly. This declaration is the same like this. Okay, so what's next? Sorting an array. Sorting an array is like this: arrays.sort. So if I arrays.sort of nums, I can sort the numbers and I can print them. Okay, so I'll change something to make this more obvious that it works correctly. And let me show you something different. You can use a comparator function like this. So you can use nums and say that if we have two elements and x and y, they will be sorted by y will be compared to x, but this will not work on ints. So you should have integer array. It doesn't work correctly because these elements, they don't have compare to. Compare to is a member of Java long integer, but it's not a member of int, which is also weak point in the Java language itself. So this will sort in the reversed order. You can also use a kind of comparator.reverse order. Do you see? It's a kind of operator, a way to express something very similar. But if you sort not integers, but if you sort something like, for example, students, you can say student.getAge.compare you, the other student.getAge. Okay, something like this. So we can have this new integer, but beware that this will not work as expected. Okay, and finally, we can check two arrays for equality like this. So if we have some numbers and, for example, nums1 and nums2 equal to new int array of 100, 20, 30, we can compare if both are of the same. For example, what I can do is arrays dot compare of nums1 and nums2, nums with s, and this will not gonna work because I cannot compare integers with ints. Again, I have this problem, but if both are of the same type, they will be able to be compared. It says that they are equal 0, and for example, if I compare like this, the second, the first is bigger than the second. This will be later than the second. But I can also use equals, and equals will say false. And if they are both equal elements, it will say true. This is how this works. So, but if you exchange the element indexes, this will be false, because it first compares the length, which is 3, and then the first element, the second element, the third element. If all of them are equal, equals returns true. Okay, let's solve a problem, a practical problem, to get some skills. I highly recommend that you write your problems and submit them in the Judge. You need to create a Java program which checks whether two given arrays consist of the same elements. You'll be given a space separated integers and you should print yes or no. For example, these two arrays hold the same elements. Why? Because this element is the same with this. These two are the same, and this is the same. How to solve this problem? The easiest way is to arrange the elements in alphabetical orders, and so this will be 1, 2, 3, and just compare whether the first and second arrays are the same. It's the easiest way. So read, sort, compare. This will be the solution. I'll write it very quickly. Arrays of same elements, or just same arrays, something like this. So I will create my main method. I will say something like it is array of integers, but basically it will work with strings as well. So if instead of 1 I have Peter here, it will also work. So I will solve the problem with strings. There is nothing with numbering calculations with numbers. So something like string, first array is read array, something like this. I will press Alt Enter to generate this. Okay, and the second array will be please read an array. I will sort r1.sort. I don't have sort. I can have stream then sorted, but I'll say arrays.sort of the first, then arrays.sort of the second, and finally I will print whether arrays.equals of first and the second. If this is true, I will print yes, otherwise I will print no. This is something like this, and I'll have scanner equals to new scanner of system.int in, and I will return the next line, string array equals to scanner dot next line dot split of space. Oh, it's quite easy. I even don't think that I will need this function read array, because it's just one line of code, and I can move this here, and let me check. Oh, what happens? Control V. I wanted to paste this. I will remove this and I will run this code. So if I have 1, 2, 3 and 3, 2, 1, they are the same. If I have 1, 2, 3, 4 and 1, 2, 3, they are not the same. If I have 10, 20, 30 and 30, 20, 10, they are the same. If I have 10 and 10, they are the same. And if I have 5 and 6, they are not. Looks like it works correctly. So let's go here and check whether this same element arrays, whether the judge will accept my solution. I will wait a bit for this to be processed by the judge, and yes, it's accepted. So this is another solution here based on streams. So I get the next one, then I create a stream from this one. I map this to int to have a int stream here. Then I sort this and transfer this to array. Finally, I have array of strings, of ints, sorry. Then I have the same for the second line of code, and I check whether they are equal or not. This is the solution, so please write your code to make sure you can solve this problem. Let's explain how the Java formatter works. I'll make some overview. We'll explain the format strings, specifiers, and some details, which we have already mentioned when we were talking about systemout.printf. So, string.format, it's a method which returns a formatted string by given locale, format, and arguments. And it works similarly to the printf method when we format a given string. This is an example. So if we have some string like this one, and if we have some format string or pattern based, it's called format string, we can transform with this invocation this parameter through this string and receive output like this. So let me show you how this works. So I will create a new class which will be called formatter examples, because what I will do is to show you examples with the formatter. And we'll create a main method, and here I can do something like printf, and I'll tell, for example, I am person S, and I am person G, years old. This is something very simple, and I'll have name and age, which will be declared first. Name is, for example, I'm Mariah, and int age is, for example, 23. And this is what I have. I'll need a new one. Int. Okay, when I run this, it works very well. But what will happen if I have, for example, a class student which holds private string name and private int age. Okay, and I want to have out insert. I will generate out insert doesn't work for some reason. Out insert, yes, generate constructor, and I will need to string out insert. It doesn't work for some reason. Okay, I'll use this generate to string, and if I use generate to string, I cannot do this one. For example, because this will print out. I need to return a string. So what I can do is something like string result equals to string.format this specifier, this name, and this age. So if I need to return something, and here I will need to return this result, or I can just optimize this like this, return this one. Okay, and now I can have var student equals to new student Mariah 23, and I can have print the student. When I run it, it will be the same output. Okay, so what's the idea here? The idea is that string format is a function which returns string, and system out printf just prints something. Internally, all of these functions use the so-called formatter. Do you see? Formatter.format. Formatter is a class. It's called Java util.formatter. And it's a complex class which can format many things. This is the explanations here, the format strings, hours, times, many things. But I will talk about all of these things later. I just wanted to show you how these formatting examples work. So let's go back to the slides, and I will show you some of them. So string.format formats a string by a pattern and returns the result as a string. We have many format specifiers, such as, for example, %p, which returns true or false for no or non-no, depending on the value. %c for character, %d for integer types, %e for floating points, numbers, and it may have additional specifiers. %f and %s and %d are the most commonly used formatters for integer numbers, for floating point numbers, and for strings. But %end is the new one, so I can use %n instead of this /n, which is better because this is the new one which will be correct for the current platform. For example, at MacOS and Windows it will be different. Okay, so let's go ahead with some other examples. So if we have the age as double and like this, I can format person.to digits after the decimal points and floating point. You know already this, it will be something like 23.00, or the girl could be aged of 33.5. It will be formatted as 23.50. And let's show you %e %e runs like this, it will be the scientific notation. It means 2.35 multiplied by 10 to the power of 1. Or if we had here 3, it will be multiplied by 10 to the power of 3 by 1000. Okay, this is the scientific notation. It is good for very big or very small numbers which are close to 0, and very big, such as billions, trillions, and etc. For example, the distance from the Earth to some foreign galaxy. Okay, so let me show you some other details about the string formatting. We can use this %. I want to show you these examples. %d, but with 6. 6 means that the output should be placed in a place consisting of 6 characters. And if the result is less than 6 characters, there will be spaces up front. So it's a right alignment. So -6 means to do the same, but to leave the spaces at the right. Of course, if we have more than 6 digits here, there will be no spaces and everything will be displayed. And we can have 0,6, which puts zeros at the leading positions instead of spaces. And we can have even something more complex, which says 0,6, which means please fill with zeros up to 6 positions with 2 digits after the floating point, and this will be a floating point number 3.5. So this 6 means that this will be 6 positions. This 0 means that we'll put zeros, leading zeros, to fit up to 6 positions in the output. 0.2 means to have 2 obligatory, to have exactly 2 letters, 2 digits after the decimal point, and F means floating point number. So this is how this works. I can show you all of this like this, for example. So I will print this as out. Don't print ln of this thing, and I will use similar things. -6. I have also 0,6, and also, oh, I don't have the closing bracket, excuse me. And finally, I will have 0,6.2f, and we'll have, for example, 1.3. And when I run this, I have this. If I put 16 instead of 6, you can see what will happen. This looks very much like a receipt from, for example, from something you have purchased over in the local supermarket, for example. So they have such alignments sometimes. So if I remove this 0, I will have 16 digits here, 16 spaces here, but this will be right aligned with 1.3 with 2 decimals. If I have 5 decimals, this will be like this. If I have less, not 16, but for example only 3 spaces, you'll see what happens. They are more than 3, but there will be no space put. If I have, for example, 20, the total space will be 20, but it will never be less than the specified. I mean that the number will never be cut in order to fit into 20 characters, into the space of 20. So this is how alignments work. You can you can read more when you open the help for the string.format, and this is the documentation from Java 1 string. I'm sorry, for string.format, and you need to open the documentation for the formatter class. I'm sorry. So it explains that this is an interpreter for printf style format strings, which can format main data. We have some examples here. We have sometimes such as dollars and other which specify indices and many other things. You can have also locales, for example, to use the French style of numbers, not the American, and many other things. I don't have enough time, but you can see that there are a lot of formatters. For example, you have time conversions, you have floating points, you have some others. I will not mention all of them. So let's go ahead. The Java util formatter is the class which is internally used in string.format and in the system out printf to format the string by pattern. It formats strings by certain format string, or it's called pattern, and it has formats for numeric, strings, dates, and others, and it has alignment, justifications, and many other specifics for the formatting, and this is how we use it. We can create a formatter and say formatter.format, which works exactly like string.formats, which is more convenient by my opinion. Okay, so this is how we create a formatter object and how we use it to format a value in a way very similar to system out printf. So that was all about the Java formatter. Let's continue with something more interesting, at least for me, working with big integers and big decimals. I will explain what are big integers and big decimals, how to use these classes, their basic methods, and some advantages of using these classes instead of the standard built-in int, long, float, and decimal primitive types in Java. So big integer in Java holds a big integer number. For example, it can hold this number, which will not fit in int, long, and some primitive types. And this class provides all basic mathematical operations with big integers, such as addition, multiplication, subtraction, etc. So this is how we declare a big integer and we assign the value of 15. So we can later add 10 and print it like this, and we can even divide by 2. 15, if we divide 15 by 2, we'll have 7 as an integral result from the division and remainder of 1. You know this very well from the mathematics. So let me show you how this works. I will create a new Java class called big numbers, for example. The name should always tell you what's inside. So I'll say var x equals to new big integer of 15. Looks like the constructor is missing, so you will need to invoke the factory method .value of. I don't know why they created this class to work like this, but it's how the Java API works. It doesn't depend on me. So if I want to add some value, I cannot say x equal to x plus 10, for example. No, I should say x dot add and try to add 10. This is not possible, so I will need BigInteger dot value of 10. The API is slightly not very good, and this is the warning which says that if I do this, x will never be changed. So if I print x, it will stay 15. Why? Because BigInteger is an immutable class, so I need to assign the result into another variable. So the value in the variable x can only be assigned, and it cannot be changed because this class is immutable. So if I want to add something, I need to store the result in another variable. It's the same with the string class. If you invoke string.replace, the string will not be changed, but the new string variable will be returned, which will hold the change. And this is how I can fix this broken code. Now the result will be 25. But I can work with long numbers. The problem here is that I cannot give this, but I think I can give this long number as a string, or maybe I will use parse BigInteger dot value of dot. They don't have much. I think it should have some kind of parse method, like parseInt, but looks like it's a private access parseInt. They have parseInt, but they don't allow it. ParseInt, integer.parseInt, parseInt, create integer, but why they don't have it? Okay, I will look in internet because I am a little bit frustrated. BigInteger parse Java. So how to parse a BigInteger in Java, and new BigInteger of myInt, and yes, but this is not what I'm looking for. Maybe I can do new BigInteger. So if I use a string in the constructor, it will parse it correctly. So this is some strange in the API. Why they don't have BigInteger.parseInt? Why they don't have a constructor with just a number? It's a bad way to create an API. API should be easy to use, and Java people don't follow this. I don't know why. Python people follow this rule, and also C# people, but this is another story. But what I had to tell you was that you can work with long integers, because this cannot be assigned in a long. Do you see? Integer number is too large. This is the main concept, and I can divide, for example, int d equals to result dot divide, and I can divide to, for example, 20. New BigInteger, and this will be integral division. It will give me just the it's not int, it's BigInteger, and I can print this d. This will be an integral division, and the non-integral part will be lost. And I can say divide and remainder, and it will be something like this. It will return a pair of two numbers. The the integral part and the remainder. Okay, so this is how this works, and this is an example of calculating factorial. We start from 1, dot 1 is 1, just 1, and we multiply by I from 2 to n, and we return. So I'll create a similar function, static big integer factorial, okay, in n, and var result equals to big integer dot 1 dot 1. Okay, I'll start with 1, and then I will say something like for I from 2, because I don't need to multiply by 1, by 2, by 3, 2 to n inclusively. I'll say result equals to result multiplied by I. But how to express this through the big integer API? Result dot multiply big integer dot value of I, and finally I will return the result. And now I can calculate, for example, factorial of 5. 1 multiplied by 2, 3, 4, 5. Looks that I forgot that this is immutable, and now this should work correctly. 1, let me show you. 1 multiplied by 2, 3, 4, 5, it's 120. Works correctly. Let me calculate 50 factorial. Works correctly. 500 factorial. It's a little bit longer. I can either switch on this. And 5000 factorial. And so on. Of course, this is not unlimited. This will take some time, and maybe it will end up in memory overflow or something like this. I'm not quite sure, but if you start here the process, you will see that we have something which takes more and more memory over time and takes a lot of time. Okay, this will not finish soon, so I will avoid calling this, but you can calculate 5000 factorial. This was the easier part using big integer. Now the more interesting part is using BigDecimal. Why it's more interesting? Because working with decimal numbers is a challenge in computer science, not only in Java. Let me show you why. Because you cannot do anything with double. If I have double, a equals to, for example, this number, okay, this is absolutely okay with Java, with double. And if I have b equals to 0. Okay, I'll put leading zeros, 3, 7, 3, 0, 0, 0, 1. And if I print the result a plus b, maybe the precision will be lost. It's 20. Okay, if I put some more of this, we'll have a problem here. it's 5.0. Do you see? These digits were completely lost. If I have less digits here, it's still lost, but I want to show you that it has precision. Do you see? 374, 374. The last two digits were lost. Why this happens? Because double has a fixed precision. Its precision is limited by the internal representation in the IEEE 754 format, which is 64 bits. And some of them are used for the digits, and the others bits are used for the so-called exponent. It specifies where is the place for the point, for the decimal point. And with BigDecimal, if this were var a equals to new BigDecimal of this one, okay, and b is a new BigDecimal of this one, now the output will be correct, but it will be the output should be a dot add of b, and now the output is it's not really correct. Why? Because this is double and it's not correct. You should work start with string based values and they will be correctly parsed, because if you put double, it is already incorrect. Why you at the time you create the BigDecimal object. So now I don't use double anywhere. I have string, I parse it to BigDecimal, and have another string, I parse it to BigDecimal. It will be parsed correctly, and I add them, and finally I'll get the correct sum. This is what I need. So you can think about financial calculations. For example, at the stock exchange, some tickers may have price 0.10 zeros and 1. So this not how to say, this incorrect calculation may have very big impact when you work with money. So this is another example how we can multiply this number by this number, and the result will be correct. So I will copy this example just to show you this one, and now the result will be like this. And I print m dot to plain string, because otherwise it might be a kind of rounded sometimes. So if I say m equals to, if I multiply this several times, it will grow and grow and grow, and I'm sorry, n and n. Okay, it works absolutely correctly. We don't need this to plain string. It is my mistake. So if we use BigDecimal, we have also control over the rounding, because if you didn't know, there are many kinds of rounding numbers. For example, in some numbers, 5.5 can be rounded to 6 or to 5 or to 5, or and for the negative numbers like minus 2.5, it may be sometimes minus 3, sometimes maybe minus 2. So we have different kinds of rounding. For example, this half even rounding is rounding some numbers, the even numbers to down, and the other the positive numbers are up. How to say, bunkers rounding. I need a kind of image to explain this better, because bunkers rounding. Sorry for this. Because it depends on many. This is the rounding. Something they have. Okay, I will not use this. But what I wanted to tell you is that sometimes 5.5 is at the edge between 5 and 6. If it is bigger than 6, it's clear that it should be 6. Here it should be something, it's closer to 5. But here 5.5 is exactly at the middle between 5 and 6. And if we always round up to 6, if we sum 1 million bank accounts, for example, the mistake will be accumulated. So I can, if it is 5.5, it could go here. If it is 6.5, it will go here to 7. So this is the bunkers rounding. I didn't explain very well, but trust me, there are several ways to round numbers, and you have control over this. Basically, BigDecimal consists of big unscaled integer, something like BigInteger, and a 32-bit integer scale. Scale means where the point stays. So if the scale is 0, this number will be 0.50, etc. 2. If it is 2, it will be 50 point and the rest. Okay, so I want to show you another example. This is very frustrating for beginners who don't know that the double type in Java and in programming generally, for example in JavaScript, on your mobile phone, depends on the software, but basically in your processor, in your CPU, it doesn't work correctly. Why? It's a long story, but in short, the IEEE 754 standard, which is hardwarely implemented in modern microprocessors, it doesn't support numbers such as 0.03. Once we do this, A will hold a value which is close to this, but it's not exactly this. I can show you. So if I print f this %.50f and a %n, you'll see that 0.03 is percent. I forgot the percent. With 50, 20. Let me check this. Okay, this looks correct, but in fact internally this is rounded during the printf, but internally 0.03 is not stored exactly, and it holds an error starting from this one. So do you see what happens? If this is this, if the first number is this and the second is this, the result should be this, but it's not. Let me show this. C. I have a problem here. Again, this is not bug in Java. This is bug in your CPU, your hardware This is bug from Intel, from AMD, in your central processor of your mobile phone. This comes from the standard. And if you want to fix this, you can just work with BigDecimal and it works correctly. BigDecimal is something that works absolutely correctly, but you should beware, because when you divide it, sometimes it might not work as expected. So if you divide, for example, 10 by 2.0, we have a normal division and the result is 0.2. But if we divide to something where there is no normal division, there is a remainder over the division, I'll try something else. If I divide by 3, 1 by 3, it is endless. The result is endless. 0.333333. If I divide 1.0 by 3.0, B. Oh, it's A divided by B. I'm sorry. It's the opposite. So non-terminating decimal expansions, no exact representable decimal result. Do you see? You get an exception because the result will be something like 0.33333, etc. Okay, so you can tell that you want to use, for example, 100 digits here. And now I will need a rounding mode. Let me show you. Divisor and rounding mode. Rounding mode dot half even bankers rounding, and I will need first the scale and then the rounding mode, maybe like this. Okay, and now this will gonna work and it will cut the result with the scale of 100 digits, but this works correctly. So BigDecimal and BigInt work better than the others. So, but what's the difference? BigDecimal holds potentially unlimited precision. You can control this. Double has limited precision, which is limited by these 64 underlined bits. Calculations are always correct unless you agree to lose precision. At this example, I agreed to lose precision after the 100th digit. And some numbers in double cannot be represented exactly. For example, 0.03. It's a big story, but in general, some numbers cannot be stored in double. That's it. And sometimes some very simple numbers like this one. And BigDecimal is ideal for financial calculations because it doesn't make mistakes, and double may result in incorrect calculations. Sometimes, not always, but sometimes. But BigDecimal is slower. Why? Because double is hardware implemented. It follows the already mentioned IEEE 754 standard, which is a big story, but this is hardwarely implemented in the CPUs. And it's very, very fast. So, for normal calculations with floating point numbers, you can use double. For financial calculations, use BigDecimal. If you want to use big integers, use BigInteger. Okay, so let's solve a problem, practical problem, so you learn how to work with these APIs. We need to create a program that calculates a total amount that a person owes after applied interest rate in percents. So let me show you an example. If I have $100 and 5% of interest rate, at the end of the deposit period, I'll have $105. It's the same here, and if I have this sum and this percentage of interest, the amount will be this. It will be something like multiply the first with the 100 plus the second, okay, number divided by 100, because this is in percents. Okay, so this is what we should calculate, but we should do it without losing precision. And we can do it without losing precision because we have division by 100, which never results to endless result, so it will be quite easier. A solution could be something like this. Let's write it from scratch. So it is interest calculator. I will create in my IntelliJ IDEA a new class called interest calculator, and inside it I will put public static void main, and inside it I will do scanner equals to new scanner of system.in. Okay, and next I will read the first number. The first number will be string num1 equals to scanner.next line. Okay, the second number will be num2, or maybe it will be, I can do something like BigDecimal, and to give us some good amount, I'll enter, import the class. It will be new BigDecimal of what I get from the input. I will repeat this as well for the second. It will be interest, and because this interest is in persons, I'll do it to be not in persons. So I will have interest equals to interest dot divide by 100, and I will need new BigDecimal of 100. Okay, BigDecimal, and now I have the interest. So BigDecimal result will be equal to amount multiplied by 1 plus interest. Why? Because if I have, for example, 6 persons, this will be 0.06, and if I multiply num by 1.06, this will be 6 persons. So this is how this works. So I need to have BigDecimal.1 dot add the interest. Okay, and it will be not this but dot multiply. It's a little bit strange because in Java they don't have overridden operators. In C# this will look simpler, but that's life. If you code in Java, you will use the Java syntax. So finally I will print the result, and let me check whether this works or not. If I have 105, run this. 105, I'll have 105.00. If I have this two, I will paste them. Okay, Control V. Looks like it's the same value. Okay, let's go into the judge and check whether this is correct or not. Submit. I will wait a bit until the judge process my submission, and yes, it is correct. If I do the same with double, trust me, the output will be different. And it will not run correctly. With double, you have a problem here at this input because rounding will break up your result. Okay, so this is what I had to tell you about BigDecimal and BigInteger. Remember to use BigDecimal for financial operations. It is slower, but it works correctly, unlike double. Let's now talk about dates and times in Java. I will explain the Java Time API and will give you lots of examples and will solve a practical problem with Java Time. So java.time package provides date and time API in Java, classes and methods to work with name, time, and calculations such as parsing a date, creating a new date, parsing a time from a standard format, printing a time in certain format, etc. Basically, it supports the ISO 8601 standard for dates and times, which basically explain how these strings represent date and time and what does this W means, etc, etc, etc. But it also follows the local settings for your machine through the locale class, as I will show you later. So the important classes are local date, which holds year plus month plus day of the year, local time, which holds time with hours, minutes, seconds, and milliseconds, and local date time, which combines these both. This is an example how it may look like. Also, the date time formatter is used for parsing and formatting dates, and we have some other classes like chrono unit and others which provide calculations with dates. Let's go deeper. Date and time can be created like this. Local date.now prints the current date. So let me show you some examples here. I'll use this main method, for example, and I can create something like this one. Local date t equals to new I cannot use new local date. I need to import it java time.local date. Okay, it doesn't have a good constructor, so you should use in Java. If you don't find the constructor, you may use some kind of static factory. So I could create local date of 2021, for example, 8 to 29, and if I print it as out, okay, it will be something like this with hyphens. And this is the standard format declared by ISO 8601 standard. So what else I can do is something like local date.now. Please give me the current date from my machine. So currently it looks like it's 9th of December of 2021 year. Okay, so what's next? I can access the portions of this. For example, I can check which is the year. Also, I can check which is the day of week, for example, and it will tell me Thursday. It returns enumeration day of week, java time.day of week, and when I print it, I see this output. Also, I can check some months, etc, etc, etc. I will not show you all of this, but I cannot change the t.set year of 2000, for example, it's not possible because this class is immutable, which means that once you create a date, you can never change it. It is immutable, unmodifiable. Okay, so you can read the dates, you cannot create them. Okay, additionally to local date, we have local time, like this. Local time t equals to local time of now. Give me the current time. The current time looks like now. It is 16.20 and 16 hours 28 minutes 46 seconds, and these are portions of the second. These are the let's say milliseconds. So I can tell you how many hours are this, and it will tell me it is 16 o'clock with some minutes. And how many nanoseconds are there, and it will tell me these are the nanoseconds from the time. I should print the time itself to see how this works. So these are the nanoseconds, and these are the seconds, etc. Also, I have local date time, which combines the previous two data structures. So if I print the date time now, it will tell me something like this is the date, t, this is the time, and these are the nanoseconds. I can create a date time. Date time equals to local date time dot of, and I can say a year, for example, something like this: day, year, month. Okay, so I will use year, month, then day of the month, then time 12:58, and this will work like this, for example. And it doesn't have nanoseconds, they are 0. So basically this is how this works. I have already demonstrated this, so I'll go ahead and let me show you how we can parse. You know what parse does mean. Parse means to transform from string to another type. For example, parsing integer transfers string value to integer. Parsing a date transfers from string value, like this one, into date. So we can use like this. I'll just copy the example because I don't want to write it. This example shows you that we can parse this date, okay, and we can print it, and we can even add 10 days. Dot plus or dot minus, you can add days, months, weeks, etc. And if I have 28th of December, if I add 10 days, it will be the next year, January 7th. These are the calculations and the results. Okay, but what will happen if we have month 7? It will work similarly. After 10 days, it will be, after July, it will be August. But if I put it like this, the parsing will fail. Why? Because the ISO A601 format says that it should always have a leading zero here. This is how it works by default. Okay, so I can print a date like this. if I have the date, I can print it in a full format. What does it mean? That I can use date.format, like string.format, and I will give that I will need a full format. Let me show you what does it mean. It means Wednesday, July 28, 2021. This is the full date format. But if you live in some country and you have changed your regional settings, this could look differently, because with locale dot, let me show you, locale, by default my locale is US English, but if I press locale dot, for example, United States, okay, the result will be like previously. But if I press France, it will not be Wednesday, it will be the French for Wednesday and the French for December. Do you see the difference? If I put Spain here, I don't have Spain, but in, for example, Chinese, it would be quite different, because in China dates look like this. Okay, so by default the current machine's format is taken. You should know this. And finally, you can print a date in certain format. Then date, month, year, for example. Or I can print 4-digit year, 2021. Okay, short year and long year. And this is Joule. This also comes from my machine settings. If I use this one, it will be the month, 07. If I use small letters here, this will be incorrect, because small letters means minutes, not months. It's very similar with local date time. You can use the same formatting things. So this is how we format and parse, and we can parse a string to a pattern. So if we say local date.parse, for example, we can provide here a second argument, which is a date time formatter dot pattern, and here I can press, for example, y month date, and now it will be correctly parsed. But if it is like this, if the date is given in different format, it will fail to parse, and I can change the pattern. And beware, if you have months names with letters, that current locale can be important. Some other examples: we can create a date like this, date.of, and we specify the details, day, month, year, etc. And we can create a locale like this, the Spanish locale, and here I create a French. I use the Spanish locale with this pattern, where the month will be the Spanish for December, and I use the full style like this. I have already shown this, so I will just copy this example because I already have demonstrated this for you. So I have a date, 23rd December, for example. And if I print it with the Spanish locale, it will be this one. With the French locale, France, it will be this one. So you have language and country. So I can even put here Bulgarian with BG or China with Chinese. or Canada, and it will be some serial collectors. So this is how this works, and that's all I want to show you about dates and time. Now it's time to solve a problem. You are assigned to create a Java program which reads a date and calculates the time left until the new year, which is the 1st of January at the next year. If it is already 1st of January, you will need to wait for the next year. So if we have 29 December, after 3 days it will be 1st January. 1 day is 30 December, 2 days are 31 December, and 3 days, after 3 days we have 1st of January. And this is another example, another example, another example. And there are some hints to use the local date time class. I think we can use even local date without time, because the time it's not important here. And also we should make our solution universal and not to believe that the year is 2022, for example. And we can use this chrono units dot days dot between, because it's a very good API which works for dates, times, and other similar chronologies. Okay, so we read the date. It is in the standard format. We parse it and we make calculations. I will solve this problem right now like this: new Java class days to new year. Okay, I will create my main method. Then I will create a scanner. Scanner equals to new scanner, because I will read some input data from the console, and I'll say local date d or date, Alt enter, will be equal to local date dot parse of scanner dot next line. I will parse it, and because this is the default format for dates, I don't need to specify a pattern during the parse. I will use the default date parser. Then I will do something like this. Date, I have date, and I need to say something like local date equals to date dot plus days. I need to create the new year. Local date new year. This is a date where the year is the date dot current year plus 1, the next year, and the date is 1st, which is January, and 1st day of month, which is 1st. So I created the new year holds the current year plus 1 at the date of 1st January. So this is the new year, the upcoming new year, at the next month. If we already are 1st January, the new year will be the next year, new year. Okay, so let's continue. Now we want to have date dot something like days between. Okay, I will just tell you how it works. Chrono unit class. Oh, chrono unit dot days dot between the date and the new year, and int days equals to this, and it returns long, not int, and I will just print it. Let me check. 2021, 29th December 2020, 29th, 3 days. Okay, if I have this one also, it should be 155 days. Looks correct. And if I have 1st of January of 2024, the new year will come after 366 days because it is a leap year, 2024, and it has 366 days. Okay, that's all with this solution. We have some similar solution here, and I will submit my code here to check whether it's correct or not. I highly recommend that you solve all your problems and you check. Oh, it says that could not be parsed. The Java, let me show you the input. Why this doesn't work? Oh, it doesn't work because I don't have the tests. I'm sorry, but believe me, I will fix this. This is a bug in the Judge. I will fix it. Okay, so let's go ahead and summarize what we have learned today. Today we have learned that Java 1 Command provides basic numeric mathematical operations such as square root, absolute value, floor, cell, round, power, cosinus, sinus, etc., etc., etc. Java 1 random is a pseudo-random number generator which can be initialized by a seed or can be directly randomized, initialized with a random seed, and you can call next int, next double, etc., etc. You can generate random numbers within certain given range. Java 2 arrays implements array manipulations such as list, sorting, equals of arrays, toString for arrays, and it works with arrays of primitive and non-primitive types. And when you work with primitive types, beware that sorting and some other things may not work as expected. Java 2 formatter is something used by system out printf and string.format, and you can have %d, %test, and other format strings, and you can format by patterns. BigInteger and BigDecimal implements big numbers, and you should be aware that big decimals can run with many digits and calculate for example, 50,000 factorial. And BigDecimal works very well for money and financial calculations because the normal double works incorrectly in some situations. Both these classes are slower than the built-in int, double, and long types because they are hardwarely implemented, and this is softwarely implemented, which is slower. Java time package and its local date, local time, local date time, formatters, and chrono unit are from the Java API for dates and times, and you can parse dates, you can create date, you can get the current date and time as well, you can print the dates, and you can work with the locales and adjust the format of the dates at the input or at the output to match your current country, and for example France or Spain. So this is what we learned today, and some of this can help you at the Java Foundations exam tutorial. So now it's important that you solve your coding exercises, because without coding exercises, you will learn nothing. Learning is done by doing, not by listening. Remember this, so code, 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 code. Write code, otherwise it will not be efficient for you. So, did you like this lesson? Do you want more? Join the SoftUni Learn to Code community at softuni.org. And remember to subscribe to my YouTube channel, Code with Nakov, to learn more about how to program in many languages, not only Java, but this is a very good channel for developers. So at softuni.org you will be able to access the free coding lessons, to get help from mentors. We have people who will answer your questions. if you have questions and you write them, and you will meet other learners because we have a community, and all this is free, totally free, so don't forget to join now. Goodbye, and see you in the next free coding lessons. Go to softuni.org to become a developer.